Hello, everyone. I'm super excited to welcome you all to our April Impact Spotlights, which is AI in nature. So let's just get it started. For our very first stop in this AI in nature tour, it'll take us to Smart Lake, which is an early detection of algae bloom.
Thank you, Hackster, for this opportunity. Hello, my name is Sashrika Das, and I am here to talk about my device called Smart Lake. So, I'm a freshman from East Lyme High School and am a maker enthusiast who focuses on innovating to help the community. So, in the summer of 2022, a tragic incident occurred where a dog parent had taken her dog to the lake for a swim, but she hadn't noticed that there was algae in that water body. So, on their way back home, the dog was panting very much and was taken to the emergency, but unfortunately couldn't survive. The reason for that was being the dog had some of the algae from that water body. So we created a device which is equipped with multiple sensors to be able to detect whether there are algae blooms in a certain water body or not, so that instances like this would be less occurred. So algae is an important part of our ecosystem because it produces about 50% of Earth's oxygen, but there's certain harmful algae, which is basically just like the overgrowth of certain algae species. For example, toxic blue-green algae, which is the kind of algae that is more common in our water bodies near us. So HAB, or harmful algae blooms, increase the pH level of the water body, which could reach about 8 to 10. And some of the factors that could be favoring HAB growth is the increase of water temperature, which could reach about 60 to 80 degrees Fahrenheit for algae blooms. So, besides defining the pH levels and the temperature of the water, some other factors, including turbidity, which measures the clarity of the water, and TDS, or total dissolved solid, which is basically exactly what it implies, the dissolved solids in the water, for example, like nutrients, for example, nitrogen, and using those factors, including pH and water temperature, can be able to give us some closure whether there's algae in the water body or not. So the hardware I used for my device was the SeedView terminal, where I was able to utilize the display on the microcontroller, the Wii terminal chases, the pH sensor kit, so I was able to get the pH data, the turbidity sensor, temperature sensor, and the sunlight sensor. That sensor goes hand in hand with my turbidity sensor because in the case it's cloudy out, the turbidity sensor, it measures like the clarity of the water. So to make sure if it's actually sunny out, it's not just reading it as cloudy. And the solar panel and battery, so it will be able to have charge while on the water, which would be ideal for when it's actually running like in real time. And for my software, I'm using Arduino IDE to code it, AWS IoT, Edge Impulse Studio to run my machine learning model, Amazon AWS Lambda, Microsoft VS Code. So I collected data from nearby water body in our town and had collected each of our sensor data. So I was able to plug them into my machine learning model with the help of Edge Impulse. And I created the model to be able to identify algae using all of our sensor data. So once the data is retrieved, then it is sent to Helium through LoRaWAN protocol, which is then configured into the Helium console and then is forwarded to the AWS cloud for further processing so that the data can be saved and then will be put into the React app, which is our dashboard, which here on the screen. That data is then received, and then it is saved into the dashboard and pinpointed into which location the device is in. And so here I have a demo of how the device actually works, with all of the sensors going into each of the holes, and with a bin underneath with some clear water, because I wasn't able to run that into a lake with algae. And then here on the Rio terminal display, you have each of the sensor datas measuring. Yeah, and so that is the device working. Oh, and then for further steps, I'm hoping to be able to get some more data through more water bodies with algae in it, because where I was testing, I didn't have those resources. So I'm hoping to be able to get some more testing done so that my machine learning model will be more accurate. All right, so thank you for listening to me talk about Smart Lake, and thank you, Hackster, for this opportunity to talk about my project, and hope to see you soon. Bye.
That was awesome. And I'm so excited for us to head into our next stop on AI in nature. And we'll be looking to the skies for a project featuring AI and remote birding.
Thanks especially to Hackster for sponsoring this. And I hope you're ready for a few minutes of some of the more maybe impractical but slightly silly machine learning or edge AI you've ever seen. First, a quick introduction. My name is Rob Lauer. I'm Director of Developer Relations here at Blues, which is a wireless connectivity company, and we love Hackster as our primary destination for documenting real-world and, yes, sometimes ridiculous projects that utilize our technology, just like this one. This project in particular all kind of started for me some time ago when I realized that I was kind of becoming like this guy, right? Calling people to come look at the bird feeder. But being an engineer, or at least kind of pretending to be, I thought more about creating a device that could actually do this observation work for me, this identifying birds at a feeder. Maybe do it automatically, maybe send a notification over SMS or something like that when a bird is identified. I don't know, seemed kind of cool. And at Blues, frankly, we live by this tagline that complexity kills. And I really do take this to heart with every project I build and document. So how could I attempt to solve this problem in particular, keeping in mind it's a pretty hard problem to solve, but I didn't want to make my life more difficult in the act of solving it, if that makes sense. So let's try and keep things simple here. And I quickly realized that, of course, this kind of became one of the more obvious machine learning, or again, edge AI, as it's more commonly known as today, that kind of a project. And, at the time I was kind of like scared into this assumption, though, of inferencing and especially model generation requiring really significant compute resources. I also knew any hardware deployment would be outside of my home, so I'd need to be prepared accordingly for power. And also in the same vein, I wouldn't have easy access to network, right? Wi-Fi is not going to work far outside my home, so I'd need some other means of communicating or relaying data. Not to mention, what about even creating the model file itself? Because I do know that edge AI models are really only as smart as we train them to be. And, did I have the right resources to utilize a robust model to handle all the different birds that might appear at my backyard feeder? And really a lot of key questions to ask. So how did I start solving these problems? Well, frankly, just to be careful, I started with a heavyweight, right? I used a Raspberry Pi single board computer. Suffice it to say, Raspberry Pi is fantastic, arguably overpowered for the job, not ideal for a kind of remote disconnected project as well, but we'll get to that. Especially when using TensorFlow Lite, though, Raspberry Pi is a fantastic option here. TensorFlow Lite is an open source edge AI platform, and I will say this experience was really unmatched. I learned how quickly I could put together a fun, but yes, a little bit impractical solution in minimal time with minimal compute power or compute time needed on the Pi. Now for this off-grid deployment, I did pull out the big guns and use a 30,000 milliamp power bank with pass-through charging. from a sizable 42-watt solar array. This did allow the Pi to function in a nearly sustainable fashion, running kind of indirectly off of solar for some time. And since we'd be out of range of Wi-Fi, I did go with the Blues Note card to add low power cellular connectivity. Just so you know what Note card is, it is a system on module, meaning it contains a radio and components and circuitry to all make it function as a standalone wireless connectivity module. And to use this little tiny cellular Note card, we added it to a Pi hat that we call affectionately a Note Carrier Pi. Slots right into the header on your Raspberry Pi or Pi Zero. Now, Note card really is kind of like a key part of this project because it adds almost turnkey cloud connectivity. I always like to think of Note card as occupying this boring space, right? The part of cloud enablement that we don't really want to deal with. You know, we like to build our products. We like to maybe build our cloud applications, whether that's dashboards or alerts or whatever it may be. But Note card really occupies this middle space and provides that seamless bidirectional data flow between the two. And at the risk of sounding a little salesy here, I've personally found over the years that Note card is a fantastic option for connectivity, as the cellular Note card in particular provides global cellular reach, also ships prepaid with 500 megs of data, 10 years of service. That's all bundled in. There's no monthly SIM fees to deal with. You can literally connect your product to your cloud with 2 lines of JSON code, and there's also SDKs for basically every popular language in RTOS out there. And it's built to be low power, so it consumes only 8 to 12 microamps when idle. And there's plenty of Note card options beyond cellular, depending on the radio you want to use, and they're all swappable, both in terms of the physical connector and the APIs themselves. So it's really an ideal option for connectivity. All right, thanks for listening to that. In terms of the model, I wasn't prepared to make a model of birds from scratch. That was just going to be a little bit beyond what I wanted to accomplish. However, TensorFlow Hub is a fantastic resource. It provides countless free and open source models to use. The one I used was a comprehensive set of birds from around the world, which seemed like a good idea at the time, but yes, did kind of burn me in the end, as you will see. However, I did find that the latency for resolving those images on low power hardware like the Pi with this model was pretty incredible. So with all these puzzle pieces in place, what could I actually build? Well, I did start with a PIR motion sensor that would detect when a bird landed at the feeder, followed by taking a picture with a Pi camera module, and then feeding that image of the bird to the TF Lite runtime using a tiny little app that I wrote in Python. Now, if the model returned a probability match of 70% or greater, so it was at least 70% confident that a bird was in the image, I would then send that data, meaning just like a JSON object of that data, to the Blues Cloud Service Note Hub using the Note card for cellular connectivity. Note Hub would then relay that data onto Twilio, which would help me generate a SMS or MMS message, so I could be alerted literally within seconds when a bird showed up. Sounds good so far in theory, right? And while I can't dig into the code here, I did want to show off how many lines of Python it took to utilize that TF Lite runtime in Python. Not very many. And really, when it was all said and done, the total lines of code needed for the entire project was 118, right? This includes all of the Edge AI work and all of the cellular connectivity, so pretty incredible. Now, this is the final look at my deployment. So the PIR sensor and camera are ready to monitor birds there on the left. The Raspberry Pi and battery are in a weatherproof case. Kind of a messy deployment, but also the solar array, kind of a cropped image of the solar array. So everything was pieced together. But how did it work? Well, as many of us have experienced with AI, 60% of the time it works every time. I did, however, experience some magic when that first text message came through. A bird was spotted, right? But if anyone knows what a Gallus gallus is, this is the scientific name of a bird, it's actually a tropical bird, more commonly known as a red jungle fowl. So not too likely considering I live in Wisconsin here in the States. However, this was a very fun, very informative project for me to put together. So thank you for watching this. You can certainly find this project on Hackster to read more details at bit.ly/pi-bird. Likewise, again, we do publish a lot of IoT projects on Hackster right here. If you're curious to learn more about what we do, likewise, if you want to get started with cellular connectivity, check out Blues via a starter kit at shop.blues.com. Thanks for attending.
We will now continue and head back to land for a project that prevents conflicts and protects elephants with the help of AI.
Hey everyone, this is Rishika Rajkumar and I also go by the name Arvina produced by R. And today I'm here to share how AI will be helped to prevent conflicts and protect elephants in the wild. So this is a project I published like 5 years ago, but I'm here back tonight to revisit this project. I would also like to thank Hackster for giving me this wonderful opportunity to present in the AI in the Wild Impact Spotlights. So let's get started.
So let's start this presentation. Before I start talking about the project, I would like to say a few words about myself. I am an undergraduate student and I am an AI and machine learning hobbyist as well as a cat hobbyist. I am a part-time researcher at Green Area since 2021 and I'm also part of the Hackster community since 2019, where I participate in multiple competitions and have won in 5 competitions so far. I am also a blogger and YouTuber, and this is where I publish my projects and showcase my projects. You can actually find a link to my blog and YouTube page in the final slide of this presentation. And back in 2022, I was one of the brand ambassadors of Newton AI. So that's about me, and now let's move on to the project. So to introduce this project, I would say this is to protect the largest mammals that are roaming the face of Earth. And this species is actually under threat, and according to WWF, African elephants are regarded as vulnerable, although certain populations are being poached to extinction. And on the other hand, Asian elephants are classified as endangered, and their numbers have dropped by 50% over the last 3 generations. And this is actually a serious concern, especially in Sri Lanka. And though we have present solutions like satellite GPS radio collar, electric fence that are powered by batteries, I would also like to propose one of my ideas to address this concern, which is an AI powered radio collar with a passive RFID tag to track the elephants and alert the locals. So how are we going to use the passive RFID tags? We can actually we can either attach it to the elephant's ear or its collar, and this will be picked up by the external RFID readers that are planted in elephant corridors to alert the locals and help them take precautions so both the elephant and humans are saved in this situation. So what will be needed for this project? We'll be needing a few hardware components like Arduino Nano 33BL sense. Although you can use other microcontrollers that are supported by the Edge Impulse, as long as they have a PDM microphone. You'll be needing passive RFID tags, RFID reader, beacon, and siren. So software apps and online services I used for this project are Edge Impulse, Arduino IDE, and Elephant Voices database. You can use any other programming software if you're using a microcontroller that does not come under Arduino. And the Elephant Voices database is unfortunately not available now, but it was available 5 years earlier when I did this project. So moving on to design and construction, this AI-powered radio collar will actually run with minimal power consumption as it's powered by battery. The machine learning model will be deployed to the microcontroller device, and we'll also have the passive RFID tags in the radio collar. And I was able to use the data from the Elephant Voices database and then train my machine learning model with this data. So what are we going to classify? Our machine learning model will be classifying the elephant audio into calls associated with anti-predator behavior, calls that are produced during musk behavior of the male elephant, and calls associated with conflicts. So I have presented you the audio waveform of each type of calls. And now let's hear how an elephant sounds like when it's in the group defense situation. So you can hear the trumpet sound, and the next one is how a male elephant sounds during its musk behavior. And that's a pulsating rumble. And now we have how an elephant sounds during conflict. And that's a low rumble. So I used the edge impulse to train my machine learning model, and this is actually a very good online service where you can design and create your impulse. I have spoken about this in great detail in my project page, so I'll just give you an overview right now. So we have a certain workflow for our machine learning model. So the first step is data acquisition, and this is why I needed the Elephant Voices database. Before you can actually train your machine learning model with the data you acquired, you actually have to pre-process it. So the first step is data cleansing, but this is not to be confused with data cleaning. And in data cleansing, you will actually individually evaluate the audio to eliminate noise and irrelevant audios which can affect the performance of your model. So the next part is audio segmentation, where the audio will be segmented. You can actually eliminate the noise and focus more on the part that has to be highlighted, like the spectral envelope. So the spectral envelope is actually the overall shape and the distribution of the energy over different frequencies, like you saw in the previous slides. Each call has a unique spectral envelope, and this is where feature extraction comes in. We'll be using the male frequency capture coefficients (MFCC) to extract the to actually capture the spectral envelope of the audio and help us to train our model. So the next part in model training is where you can choose your machine learning algorithm, whether they are CNN or RNN. And you have to make sure to split your data set into train and validation set, so that you can actually use the accuracies that are obtained from the training, validation, and testing to evaluate the bias and variance to address overfitting and underfitting issues. You will be training your model with the processed audio features, and then you'll be evaluating your model. And under evaluation, that's where your test data set comes in. But make sure your test data set is from the same distribution as the validation data set. Make sure both your data sets come from the same source. And you'll be assessing your performance with metrics like accuracy, precision and recall, and the F1 score. We also have the Bayesian optimization as part of the workflow, and this is where you'll be tuning your hyperparameters for better performance. And if you would have heard about the Bayes optimal error, it is actually the lowest possible error. So by fine-tuning your hyperparameters like the learning rate, the dropout rate, and the number of epochs, you'll be making sure your machine learning model will mimic the human level performance. And what I mean by human level performance is that is the individual performance of someone who is experienced with elephants, like a elephant biologist. The last but not the least step is model deployment, and this is where you'll be deploying your model to the microcontroller to be used in the radio collar. The next steps of this project would be to train on a larger dataset to reduce the bias, and I would like to expand my dataset using data augmentation and by implementing noise injection. And I would also like to fine tune my hyperparameters and refine the neural network architecture to provide a more complex algorithm to address the bias issues. So thank you for your attention. You can always visit the project page if you are interested in this project.
So thank you for listening everyone, and I hope you all like this project. So this is a serious issue that needs to be addressed, and with the help of AI it makes things much easier. And this is also helpful to preserve the number of elephants as well as protecting human lives. So I hope you all like this project, and if you are interested in this project, please feel free to visit the project page and also drop your comments and suggestions in the project page.
That was another awesome project in nature, and we are just getting started. We have a few more, and for our next stop in nature, we will look at an IoT AI-driven tree disease identifier that uses edge impulse and MMS.
Hello everyone, welcome to Impact Spotlight's April. Today I will talk about my IoT AI-driven tree disease identifier project. First, I would like to talk about a little bit my experiences. I am an independent researcher focused on demonstrating the ideas and solutions I conceptualized regarding various domains and disciplines, from industrial operations to agriculture. I was an aspiring physics major and enjoyed applied physics studies until in 2018 I decided to leave my university and pursue my vocation to be an independent researcher. I gained all of my skills in product, AI, and software development through self-education. I'm a product maker and product, AI, and software developer to try to prove my ideas regarding the different solutions. I am an Edge Impulse expert network contributor and a particle creator program contributor. You can find my related projects to their services in their respective forums or websites. I am also recently became a Hackster Pro member. So first of all, about this project, I always try to find issues before designing my projects through science articles, science magazines, news, etc. Then I try to solve these problems with my skill sets and create different solutions. Then after I decide and pinpoint solutions I want to prove in my project, I start to develop my project. First of all, what are the issues I recognize before starting this project? Due to climate change and excessive deforestation, trees and plants are becoming more susceptible to contagious diseases. Most tree diseases are fungal and instigated mainly by drought, high carbon dioxide levels, overcrowding, and damage to stem or roots. Since trees are crucial for pollination, spreading tree diseases can cause crop yield loss, animal deaths, widespread infectious epidemics, and even land degradation of the region. Various environmental factors can cause trees to be stressed and catch a highly contagious diseases, such as an abundance of some species or a decrease of another species can affect the stress levels of trees around the area. Tree diseases can endanger unrecoverable damage to forests, farms, and arable lands, leading to year-long harvest losses around the area. What are the solutions to these problems? First, detect tree diseases before permitting forests to avoid their detrimental effects. Provide precise warnings regarding potential tree diseases and environmental factors to avoid hazardous outcomes related to forest degradation and crop yield loss. Collect data from trees infected with different diseases in order to train an object detection model with notable validity. Inform the user of the detection results via MMS remotely after running the object detection model. According to your area and your country, maybe this networking option may not be suitable for you, but I will talk about it a little bit later, some alternatives. Then design a 3D printable case to make this device as robust and sturdy as possible while operating outdoors. Also, it is helpful while trying to replicate this project. Bill of materials, I utilized the Sandscape K1100 prototyping kit. It includes all of the mentioned Seed Studio products, including the Grow Vision IR module, via terminal, Grow carbon dioxide temperature sensor. I also utilized a Latte Panda 3 Delta to host my Python application and communicate with the via terminal and Vision AI module directly. Then I utilize the DF-Robot 7-inch HDMI display with capacitive touchscreen. You may not need to use that. You can directly connect with Latte Panda via SSH or other methods, but I wanted to show the results directly. Then I utilize a micro SD card with a FAT32 format. Then I utilize a 3D printer to create the case I come up with for the project. First, I start to collect environmental factors via bioterminal from the affected areas with tree diseases. I have a near forest near my hometown affected with lots of tree diseases, so I can go here and collect environmental factors where the trees are affected most. After configuring the bioterminal, I programmed bioterminal to save the collected environmental factors to a CSV file directly to the SD card. I collected date, carbon dioxide, temperature, humidity, moisture, total volatile organic compounds, and carbon dioxide equivalent values. Carbon dioxide equivalent values is the harm of the other gas emissions, like turning converted to the carbon dioxide levels. So we can see how these other gas emissions affect the global warming as if they are carbon dioxide, so we can easily determine their effects to the environment. Then I utilize bioterminal to send commands to Latte Panda 3 Delta via several communications to send the device updates. While collecting environmental factors, I also captured images of infected tree diseases via Grow Vision AI module. First, I updated the Vision AI module format to capture images in Python. You can find more information about how I utilize the Vision AI module in my tutorial. Then I utilized Latte Panda 3 Delta running Ubuntu to store the captured images. Then I programmed Latte Panda 3 Delta to show a real-time stream generated by the Vision AI module. Then I started to collect different tree images affected with different tree diseases, mostly foliar and bark tree diseases. After 2 weeks, I constructed my moderate dataset for this project. As you can see here, I collected tree disease images of leaf rots, leaf spots, leaf blisters, powder mildew, needle rusts, needle casts, tar spots, rusts. These diseases can be classified as foliar and bark tree diseases easily, because leaf diseases mostly, especially the diseases I focused on, mostly about yellowish or whitish spots on the leaf, and bark diseases are yellowish or greenish spots, mostly yellowish and greenish spots on the bark. Then I start building my object detection for my model with edge impulse. After uploading and labeling the samples, I trained my model, evaluated its model accuracy, and then deployed the model as a Linux application .aem file, which is why I run Ubuntu on the Latte Panda 3 Delta, because it is easier to run Edge Impulse model with a Linux computer. As I mentioned earlier, these three diseases are mostly have similar outcomes, the ones I focused on this project. So I basically created 2 classes with different tree diseases, foliar tree diseases and bark tree diseases, so I can detect tree disease easily with a moderate dataset. Then, as mentioned, informing the users, I utilized MMS messages to send MMS directly from Latte Panda 3 Delta to the user's verified phone number. I utilized Twilio's integrated services and account. I also developed a web application in PHP to save the modified image transferred by LaTeX on the 3 Delta. Then this web application handles the saving the modified image to the user's phone number via MMS. However, as I mentioned, MMS may not be suitable for your country or area if the services are not very reliable. Further discussions what we can achieve with a project like this. By applying object detection models trained on captured infected tree diseases in detecting potential tree diseases, we can achieve to avoid crop yield loss, animal deaths, widespread infectious epidemics, prevent land degradation due to soil erosion, mitigate deforestation, and protect wildlife. However, as I mentioned earlier, these tree diseases may have some potential effects on the area, so we need to detect it easily without losing the data to networking services. So in my next project, I wanted to improve this project and create a different and add a different networking service. Even though I focused on a different subject, detecting fertilizer pollution in my successive project, it is more of a spiritual successor to this project than a direct new iteration. In my new project, I utilized most of the same devices and services, but I swapped the Grow Vision AI model with LoRaWAN from, again, Seed Studio, A1101 Vision module, Senscape Vision module. Then I utilized also from Seed Studio LoRaWAN gateway network, so I can easily direct the collected data and results from the established LoRaWAN networks and receive the message via WhatsApp, again hosted on via the web application hosted on the laptop and the 3 Delta. Thanks for listening my project and presentation today. You can find the respective project pages on Hackster and inspect my other projects on my Hackster profile. Also, I have a new portfolio website, kutluanaktar.com. You can inspect all of my work on here, and you can find my other projects on my other posts on social media with the given text. Thanks for watching.
That was very cool. Hopefully my trees in my front yard are staying healthy. So now we will hear about a trail camera that uses satellites and AI for animal research.
Hi, my name is Daniel Lagut. I'm a software engineer of over 6 years at my company DevMandan LLC. I have a background in computer vision, and I typically build new products and services within tech startups. Today I'm going to be talking to you about satellite trail camera, which I wrote about on on Hackster.io. I was inspired to do this project because eventually I want to create a QR code photo booth where people can just kind of walk up and turn themselves into QR codes. I was also inspired by the remote transmission of data aspect. The idea that you could just be in the middle of nowhere, connect the data, and send it out. This is kind of a spin-off project from reading dial gauges with cameras, more so in the aspect relating to the remote data transmission. Another aspect that I found interesting in this that I didn't really see explored, but I wanted to look into was using AI models for upscaling images as a kind of like a form of like pseudo compression. Just because I never saw anyone really using it as a way to reduce image sizes or reduce the size of an image that gets sent. And then obviously I wanted to apply this to looking at animals and how it could potentially help the spread or mitigate the spread of a disease such as wasting disease in deer. So for this project, you have the Blues note carrier, the Star note card that slots into there, which gives you the satellite data coverage, and then the 4G board that also goes in there. You have the two 18650 battery holders along with the batteries themselves, the LM2596, which helps you adjust the voltage, so that way you can get a steady voltage out of those batteries. You got the Orange Pi there, which is a kind of like a Chinese clone of the Raspberry Pi. A quick shim, which gives you a way to just easily wire I2C between the Blues board and the Orange Pi. There's also a PIR sensor, and there's also a pinout for being able to hand solder the web camera that's used. So that's what this looks like right over here. And if you take a look, here you got the batteries, you've got the PIR sensor, the ability to go and keep a steady voltage out over here. You've got this shim right here for the wires for I2C that go into, let's see, where is it? That go into right here. And then you've got a way to hand solder the web camera, so that way, going from the ribbon cable to something that's more manageable to hand solder. For the box, just did something very simple. Just found a waterproof box on Amazon. Not too much thought put into that. I wanted to keep it very simple, keep it a very large box, so that way it's easy to put together. Put a camera mount at the bottom that adapts for most cameras, specifically for like a tripod. There was a back plate that came with the box itself, so I used all of that to mount the electronics. Very hacky, just some M3 nylon standoffs and M3 screws and some zip ties. Like, there's nothing special going on there. Just did some soldering and some wire wraps for that. So when this thing takes an image, right, what it does is it takes a polling image, and that means it's just every minute or every 5 minutes, depending on what you set it for, it'll take an image, and then if something steps in front of the camera, it'll take a second image. And it does this all in Python. And then that second image and the original image, a difference hash is calculated. That difference hash also has a Hamming distance calculated with it. And what that basically means is it gives you a number to understand how much of the camera's perspective is occluded or obscured. So that way you have metadata about what's in front of the camera. You get some insight about what's in front of the camera. And you also get, a plus code, which is a way of doing coordinates with only one dimension of data. So, and a plus code is typically used on through Google Maps. So from the web app's point of view, so this image gets the metadata gets sent over to the web app. Then you see it, and you can request the original image. The original image is still on the camera box itself, and the higher the Hamming distance, the more there's something standing in front of the camera, meaning that there's a very large deer or very large animals in the distance, Or it could just mean that there's a bug on the camera itself right in front of it, right? But you know that the image is very obscured. You could click request. It sends that request over back to the camera box. The camera box then takes the original image, chunks it up, sends it back. This front-end web application in Django puts it all back together, and you get the image on the right. And now the request button has turned into an enhance button, and now you get the opportunity to click the enhance button, which then upscales the image itself. And now you've just got more, just a nicer experience if you were dealing with images on a web application. You also sent less data because this AI model sits on the front end, meaning it's on somebody's laptop, and it upscales it, which is great. And it uses a library called transformers.js. One thing that in the future that it would be interesting to explore is instead of, say, sending a Hamming distance, you could start adding other AI models that are multimodal to get natural language text descriptions of what's in front of the camera as a form of sending metadata ahead of time. So instead of, let's say, a Hamming distance, you could get, hey, there's a deer in front of the camera, there's a dog in front of the camera, there's a fly in front of the camera, or a spider making a web in front of the camera. That's something that I think would be really interesting. And you could also send less data by doing that, but doing that on the Orange Pi itself on the edge. For the next steps, I was approached by some researchers who were studying the spawning of salmon in Alaska. So I tried helping them out as best as possible, giving them as much information as I could to help them. But they found me just through Hackster.io, and they were looking for a satellite trail camera, which there are none commercially available. The next iteration of this project is likely to be seen as a QR photo booth, and you can see some of the start of that work over at humanqr.com. You can follow this project and take a look at it in more detail over on Hackster.io for this project link. You could also give me a follow on Hackster.io, Blue Sky, X.com, or on GitHub. And if you scan this QR code, it will take you to my website where you could see other projects I work on and blog posts I do about AI topics occasionally. Thanks for giving this a listen.
That was awesome, and I'm excited to hear more about the salmon spawning next. So, but now we're going to take a look and get a peek into a wildlife sanctuary monitor.
Okay, hello everyone. Thank you, Hackster, for the opportunity for me to share my past projects in this Impact Spotlight. So what I want to share about my past project is past project is about wildlife sanctuary monitor. So before we start, here's a little bit about me. I'm an academic staff at Universitas Raharja. I'm also a lecturer at the same place, at the same campus. And actually I'm recording right now, still in the campus. I'm also a ranger at City Studio. In the past year, I've been doing many tiny machine learning workshops using the Xiao ESP32S3 Sense in many places, in many campuses. I'm also an IoT and machine learning enthusiast. Maybe you can check it in my project page. Most of my stuff is based on the IoT and machine learning stuff. And also I am a minor in PCB design. I like to do some PCB stuff in my free time. So let's get to the project. So the background for this project is Indonesia. Actually, Indonesia is the third largest tropical is home to the third largest tropical forest after Amazon and Congo. So in those forests, we also have some conservation area that are protecting the rare animals that is endemic to Indonesia. But for this project, I'm only focusing on two, which is rhino, based on Java Island, and also orangutan, that is based on the Borneo Island. And the problem in conservation in Indonesia is the minimum human resources. And because of the minimum human resources, there are not much monitoring of the animals that can be done by the ranger itself. And also there are no environment monitoring for the conservation area itself. And so based on these problems, I want to make this project that is focused to monitor the environment, also the animal itself. So my solution to the problem is to make a wildlife sanctuary environment and animal to monitor and maintain the sustainability of the sanctuary. So for this project, I want to build a device that is capable to do audio classification to check the animal liveliness, both based on sound and also visually. I want to make an object detection to check the animal activity, and also a fire detection for an early warning to prevent the spread of the wildfire using sound and also the sensors. And I want this device to send the results of the data monitor wirelessly in a long distance using LoRa technology. So for this project, I focus on this kit, which is later evolved into the C-Studio SenseCap K110 kit that already consists of a small TinyML sensor, which is the Grow Vision AI. And it can be easily used by anyone, easily to code, I mean. I also already have a LoRa E5 module to send the LoRa communication, and also already consists of SGP30 and HST40 sensor. In addition to the kit, I also using the C-Studio Shell RP2040, a solar charger module, and 5-volt solar panel, 18650 battery, and an additional LoRa antenna to extend the coverage of the communication. So this is these are the main objectives: sound classification to detect the orangutan and rhino, and also detect the threat, which is wildfire, and also illegal hunting, which is a gunshot. I want to make a gunshot classification. In image classification to detect orangutan and the rhino visually using the Grow Vision AI module provided from the kit. And also I want to make a wildfire detection using the sensor and send all the data through LoRa. So for the sound-based detection, actually there are not much data on the internet. So what I did is I collected the data from the YouTube. So I doing some search on YouTube of rhino sound and download the videos, the audio only, into an MP3 format. The rhino sounds, the wildfire sounds, orangutan sounds, and also gunshot sounds. And convert it into WAV before I upload it to the Edge Impulse. This is a setting that I use. And after upload all the data set necessary, this is the result. Not a very good model, but it still works for me for testing and a proof of concept of that we can do an animal detection or threat detection based on sound. And for the image-based detection, still my main problem is the data set, but I luckily find this RoboFlow data set that consisting of 5 endangered animals, and orangutan is included in there. So with this data set, I only add the rhino images, and I train the data using the C-Studio's wiki, and these are the results. And this is the testing that I made. I use the wire terminal as the interface for the Grow Vision AI to make sure if the detection is running correctly or not. And you can check the full video in my project page later after this. And the next one is sensor-based wildfire detection. So for this sensor-based wildfire detection, I use the SGP30 and SHT40 sensor, which is SGP30 is VOC and ECO2 gas sensor to read the volatile organic compound of the environment, and also the SHT40 is the temperature and humidity. I use this with the concept of the sensor fusion, and before I made the data model for this, I made the wire terminal and the sensor as a sensor capturing device. So these are the buttons for capturing the data. So if I want to capture the background data, I click this button, the left button. If I want to capture the fire data, I click the middle button, and also the smoke, I click the right button. So this is the examples that I made to capture the data that I needed. And after collecting the data, these are the results from Edge Impulse. So these are the wildfire detection based on those two sensors. As you can see, the wildfire detection is good, but I still have some false detection in there, some incorrect data in there. They still need some adjustment, more depth adjustment to make it more precisely. But maybe you can see in these videos, you can check it later on my project page. They are successfully detecting wildfire using the sensor provided. And for assembling the device, I'm using a model from Thingiverse, and I modified the model and adding some holes to mount the sensor and also the shell to easily mounted all the sensor with a screw, not with screw, with screws, sorry. And also I also put a solar charger panel on the inside. Actually, it's been blocked by the battery in there, but there is a solar charger module inside. And this is the final result of the device. So the left one is the wire terminal act as a receiver of the data, and it can forward the data into an IoT dashboard on an IoT platform. In this case, I use Blink and also Qubitro. And the right one is the capturing device. As you can see, it has solar panel. It should be self-sustained, but in my testing, it still needs a better adjustment on the power side. Because I've been using RP2040, maybe I should use ESP32 and its deep sleep feature, because RP2040 doesn't have deep sleep, so it cannot save the energy from the battery. And so yeah, this is my wildfire sanctuary, my wildlife sanctuary monitor project. And actually, there are a lot of improvement that is needed to make this project can be deployed into the real environment. So because I don't have data set for the animal sound, and also I actually wanted to capture the animal sound directly in the conservation, but still need a budget and time, and I only work in, and I work 9 to 5, so I don't have the time for that and also the budget for that. But still, if there's a better data set, I still want to make the improvement for the sound, also for the image, and also for the sensor-based wildfire detection. Also, I hope this project can inspire anyone who wants to do the same thing for their conservation area. So this is the full Hackster page, and this is my Hackster profile if you want to check my previous project. And if you want to be connected with me, this is my LinkedIn. Link. So yeah, that's it. Thanks again, Hackster, for the opportunity for me to share this project, and I hope this project can help someone who maybe facing the same problem on the technical side or maybe in the concept side. And yeah, I guess that's it. Thank you for your time, and I'll see you again maybe in the next event.
Oh, that was really cool. And so I'm really excited for our final stop on this tour of AI in the wild. We're going to wrap up with the Internet of Birds.
Hi, my name is Saudin Distarovic, and today I'm going to present my project, The Internet of Birds, using IoT to determine bird types. Brief info about me: I'm an electrical engineer. I'm working as a project engineer in oil and gas industry. In my spare time, I enjoy working on projects related to AI, particularly neural networks, computer vision embedded systems, and single board computers. A little bit about my project. I was inspired by observing birds near windows, and idea of automating bird identification using IoT and AI has emerged. The objective was to develop a system to identify bird species using edge AI technology. Background: the importance of this project: birds are vital to ecosystems, contributing as pollinators, seed transporters, pest controllers, and more. Understanding bird species and their behaviors can aid ecological conservation efforts. And also, there is exploring of a new technology in this field, so why not to use new technologies in this ecological preserving projects. As I said, the primary goal was classification problem, to detect and classify bird species using AI on edge devices. Secondary goals are to analyze bird activity based on time and season, and the objective was to provide insights into bird migration and habitat preferences. Secondary goals and objective can actually be done by using IoT and small databases for later data retrieval. For example, if you are storing the data for a longer period of time, for example, through the whole year, through all seasons, you take data and then after you can analyze in order to have more informations. For this project, I used a combination of hardware and software components. The key components were Grow Vision AI module V2 by Seed Studio. It's compact and useful, powerful hardware for edge AI applications. Grow Vision AI module has ARM processors, which also have neural processing unit, which is specifically useful for these neural network tasks. Grow Vision AI module V2 comes with Raspberry Pi camera module, which captures high quality images or videos for model training and classifications. Advantages are that these components should be cost effective and suitable for constraints environment, which they are, and easy integration with IoT systems. Software tools which I used are Edge Impulse Studio. It is a web-based platform, very simple, which has a graphic user interface and can be used, and I used it for designing and training machine learning models. Another software tool which I used was SenseCraft AI by Seed Studio, which is already pre-made, pre-configured. It has also some pre-configured models, training models, which can be used immediately, but I used Edge Impulse Studio first to develop my own model and then deployed to Grow Vision AI module, and then used SenseCraft AI to have graphical representation, actually real-time video of this classification problem. Edge Impulse Studio supports transfer learning for small data sets, and it is optimized for low power devices. What I have done in the first step is that I captured 102 images of bird species using the Grow AI camera. Dataset includes 6 classes. Among them are 4 bird classes, and 2 classes are one for testing and one unlabeled. I used Edge Impulse Studio to train the model, and I applied transfer learning to fine-tune the pre-trained image classification model. The first thing is that I resized images to 96 times 96 pixel for efficient processing, because you have 3 colors in each picture, and 96 times 96 times 3 pixels, it is large data sets. Also, that's only one image times 102 images. Extracted features and classified new data are done by using the learning block. Here the first step, as you see, is done in Edge Impulse Studio. So I first resized the pictures, as you see, in the image data column, and then transfer learning has applied with output features and input features. Input features are images, output features are 6 classes. Here are neural network settings like number of training cycles, learning rate, validation set size, and similar. I have been mostly taken by default these values, and I took data augmentation in order to get real-time simulated real-time settings. For example, data augmentation adds transformations like rotation, translation, and similar to images in order to have the like real scenarios. Input layer, for input layer I took MobileNet v2 model, and final layer has 16 neurons and 0.1 dropout. Here are the results. As you can see, they are very good. Accuracy is like 93%. In Edge Impulse Studio you have also informations about peak RAM usage, flash usage, and interferencing time, and those are useful data to know in order to deploy it on the constrained microchips. So peak RAM usage you can see, and flash usage are very small, so Grow AI Vision actually is more than capable in terms of usage of internal RAM. Okay, so demo time. You can see on this image the Seed Studios Grow Vision module with with the camera. Okay, in the last demo, you saw that the neural network with confidence of 96% has identified the bird type. So this project can be useful for various scenarios like ecological monitoring, educational use, and it has also future potential to expand it, to connect it with another systems and to get more informations and more data about it. What I learned and what the challenges were, you can see on this side. So we have a limited data set size because of the constrained memory, flash memory, RAM memory on the devices. So constraints are of the edge devices in processing power and memory, and I learned that transfer learning is very effective for small data sets, and IoT and AI integration can provide valuable ecological insights. Okay, this was a brief info of my project. So here are the informations about me and my social media links. So if you are interested in providing feedback or useful informations, feel free to contact me to comment or just say hi.
Well, thank you everyone for joining us today for our April Impact Spotlights, which was AI in the Wild. We had a lot of great projects, and I can't thank everyone enough for sharing all of their AI in nature with the whole Hackster community today. So we hope you join us next month in May as we look at industrial automation. Thanks, everyone. Have a great day.